Hello everyone. Today we will study about the magnetic field due to a straight conductor. For that we have set up an experiment in which a battery is attached, a key is there, and we are passing this current through a straight conductor XY. You know that as the current direction is from positive to negative, what happens is that the current is flowing from X to Y, right? The current is flowing from X to Y. So, we have put a hard board and whose plane is perpendicular to the conductor. So that means if the conductor is like this, the plane is like this. The plane is put perpendicular to the conductor. So before switching on the circuit, we smear some iron fillings on this cardboard. Then when we switch it on, we know that associated with every current carrying conductor, there is a magnetic field. So what happens? According to this magnetic field, these iron fillings get arranged. So these iron filings get arranged in a particular pattern like concentric circles around a conductor. So the first point that we have to note is, as the iron filings is arranged like this, it shows the nature of the magnetic field around the conductor. So what is the nature that we see here? The magnetic field lines are concentric circles around a conductor in a plane perpendicular to the current carrying conductor. So, a question can be asked to you, what is the type of magnetic field lines that is associated with a straight conductor carrying current? The answer to the question is, they are concentric circles in a plane perpendicular to the direction of the conductor, or in a plane which is held perpendicular. On that plane will be the concentric rings. So what will be the direction? To note this direction, which law will we use? In the previous class we have studied about the thumb rule, right? So the current is going in this direction down, right? Grasp the conductor with your right hand such that the thumb shows the direction of the current. So when we grasp the conductor like this, my curling of fingers is into the plane of the board, right? If the conductor is on the plane of the board and the magnetic field lines are in a plane perpendicular to the plane of the board, so it will be like this, right? Going in this direction when I grasp my thumb like this. So the magnetic field lines can be drawn like this. In this side it will be going into and it will be going out. You have to note that this hardboard is perpendicular. If this XY conductor is placed on the board, the cardboard is perpendicular, right? So when we grasp this conductor, what is it? It will be going into, if the reference to this board, it will be going into and coming out. So this is the direction shown. So what happens when we reverse the current or reverse the terminals of the battery? So what happens is that the current will flow from Y to X, so that when we grasp the conductor, what will happen? It will be in the opposite direction. Here the magnetic field will be into the plane of the board and it will be out. So to sum up, children, what is the nature of the magnetic field lines around a straight conductor carrying current? That there will be concentric circles lying in a plane perpendicular to the conductor. That is your answer. That is a very specific thing. They are concentric lines. They are concentric lines or concentric circles. You can see so many circles, like how the iron filings is arranged. They are concentric circles in a plane perpendicular to the conductor. So when I reverse the current, the direction of the magnetic field also changed. So now let us discuss what are the factors on which the magnetic field lines due to a straight conductor depends on. The first factor is, you know that the magnitude of the current. When the current increases, the intensity of magnetic field developed around the conductor increases. So magnitude of current, or you can write the strength of the current. Next, when I reverse the direction, the field line direction also changed. So we can next say that the next factor is direction of current. Then what is the third factor, children? For example, if you draw a conductor, like this, right? And I have marked a point P here and a point Q here. We know that the point Q is farther from the conductor, right? So at the point Q, what happens is that the magnetic field is lesser, and at point P it will be more stronger. So what is one of the factor on which the magnetic field depends upon? The distance of the considered point from the conductor. So what is the third factor? Distance of the considered point. Distance of the considered point from the conductor. And of course, depends upon the medium in which the conductor is placed. What is it? Medium in which. This is an extra point which is not given in your textbook. Medium in which the conductor is placed. So, what are the factors on which the magnetic field due to a straight conductor depends on? It depends upon the magnitude of current. It depends upon the direction of current. It depends upon the distance of the considered point from the conductor. And the fourth point is medium in which the conductor is placed. Dear children, when someone asks you to draw these concentric circles, you have to note that when we go away from the conductor, the field lines, the field strength decreases. So, when you draw it, the inner circles must be more close to each other than the outer circles. When we go to outer circles, we can make it farther when compared to the inner circles. The inner circles must be much closer. And when we go forward, the outer circles, the distance relative distance between the outer circles can be more, but the relative distance between the inner circles should be less while you draw it. And to assign the direction of the magnetic field lines, what will we use? We will use the thumb rule. So, again to sum up, what are the factors on which the magnetic field due to a straight conductor depends on? It depends upon the magnitude of the current. It depends upon the direction of the current. It depends upon the distance of the considered point from the conductor. And the fourth is medium in which the conductor is placed. And to sum up, what is the nature of the magnetic field lines around a straight conductor? The nature, they are concentric circles lying in a plane perpendicular to the conductor. That's all for this class. Thank you.